So before we further explore resonance features in the ocean, we just have a look at the structure of tides in the open ocean. And in order to understand the structure of the tides, just let's have a look at very simplified examples. So I want to show you two movies. Okay? One movie is the first one here on the bottom left, shows you the so-called sage motion in a closed basin. Okay, you just have a closed basin. You initiate a natural oscillation, which is shown here, where you just have something we call a wave node in the middle, in no vertical motion in the middle, and we have upward motion on both ends of your channel. Okay, this is what we call a sage. All right, in the open ocean, we do have the influence of the Coriolis force. Okay, although the periods are less than 1 day of waves, the tidal waves are influenced by the Coriolis force. And so what happens, instead of having these so-called sage motions, we get actually a motion which moves around a basin. And this is shown here in the second animation, which shows you so-called sage motion in the presence of the Coriolis force. You get is actually a motion which has no motion in the center and the maximum amplitude at the rim of your basin, and the wave actually moves around this basin. You see that? Okay? And this type of motion we can express in terms of co-range lines. So the first thing that we can use is we can use so-called amphidromic points, are the points where the tidal range is 0. Okay, so we have a tidal constituents, and for example, in the center of this example, if you look from above, in the center, no vertical movement. This is a so-called amphidromic point. Then we can use so-called co-range lines, are the lines of the constant tidal range that run around amphidromic points. Okay, these are, for example, shown here as 0.5 meter tidal range and 1 meter tidal range. So as the wave progresses around the amphidromic point, you get, at some point in time, you get a tidal range of 1 meter if you follow along this circle. The other piece of information that we use with tides is a so-called co-phase line, is the lines of the same timing, constant phase. Okay, the lines which connect all places where high water occurs at the same time. And you can see that here. So at the start point, which we call 0 degrees, one cycle corresponds to 360 degrees. Okay, so this is after you express one full period of the tidal wave by 360 degrees. And you can see the first after 1 quarter, you are here. After half the tidal period, you're over here. 3/4 of a period after start, you're at this location, and then you're back at the start. And this is how we can produce maps of tides. So let's have a look at these tides.